This video is going to take us deeper into evaluating expressions. So let's say that we're looking at this math problem right here. What could we do to make it clear which operation we do first? Well, we can remember Pemdas. Remember that we start off with parentheses, then move on to exponents. Then we do multiplication or division, whichever comes first. Then we do addition or subtraction, whichever comes first in that step. This is the same thing that we've been going over, except now we're going to go ahead and throw fractions in there just to add a little bit extra to the problem. Remember that brackets or parentheses tell us which operation to do first. So if we wanted to make sure we do the 4/7 minus 1/7 first, we would put parentheses around it. If we wanted to make sure that we're going to do 1/7 plus 2/7 first, we're going to put parentheses around that. So remember that if there are no brackets, and this is what we just discussed, we do addition and subtraction from left to right. We also do multiplication division from left to right. So our original problem from the front would be solved using parentheses on the first problem. This would be the similar equation right here. This one would be different because it would be changing the order around. Do you have to put brackets to keep the order? Not necessarily, but sometimes it can help if you want to really lay out your thinking. So let's go ahead and let's look at some of these problems. We have here 4 1/10 plus 1 3/10 times 3. Well, remember that Pemdas says, let's put it up there real quick, please, thank you. Remember that Pemdas says do parentheses first. I don't see any parentheses. Then it says do exponents first. I don't see any exponents. Then it says to do multiplication or division next. I do see multiplication. So I'm going to go ahead and I'm going to multiply 1 3/10 times 3. 1 3/10 times 3. 3 times 3 is 9. 3 times 1 is 3. There's one number after the decimal, so I put one number after the decimal. That becomes 3 9/10. So now I have 4 1/10 plus 3 9/10. And when I add 4 1/10 to that, 9 plus 1 is 0, it becomes the number 8, which is my final answer. You go ahead and try the next two, and then we're going to talk about it when you come back. Welcome back. In letter B, we have 1 5/10 times 2 plus 1/2 times 3. Well, let's take a look at what we need to do here. No parentheses, no exponents, which means we're going to multiply or divide first. Oh no, I see two different multiplication problems. Best practice always says to start at the left and work your way to the right. In reality, these are on two different sides. They're not really related to each other, so the order wouldn't matter, but it's always a good habit until you really understand the rule to start from left to right. That way we make sure that we don't mix anything up. So 1 5/10 plus times 2 is 1.5 times 2. 2 times 5 is 10. That would be 3. That would be just 3. Plus 1/2 times 3. Now we have this 1/2 times 3. So I'm going to multiply 1/2 times 3, except 3 is a whole number. I need it to be a fraction. So it's going to be 1 1/2 times 3/1. Multiply the numerators. 1 times 3 is 3. Multiply the denominators. 2 times 1 is 2. That becomes 3/2, or 1 1/2. So this becomes 1 1/2. Write down everything I didn't touch before. 3 wholes plus 1 whole and 1/2 makes 4 wholes total and a half. All done. Letter C, let's go ahead and take a look at this one. We have 1/3 times 6 minus 35 hundredths plus times 2. So remember that I want to look at what's being in parentheses or brackets first, and I don't see anything. I also don't see any exponents. So my next step is to multiply or divide. Starting at the left, I have 1/3 times 6. 1/3 times 6/1. 1 times 6 is 6. 3 times 1 is 3. 6/3 is the same as saying 2 wholes. So this becomes 2 minus 35 hundredths times 2. I'm going to multiply 35 hundredths times 2, so that's 0.35 times 2. 2 times 5 is 10. 3 times 2 is 6, plus 1 is 7. There are 2 numbers after the decimal, which means this is going to be 7 hundredths. Remember that I don't need to write this 0 because it's at the very end, and the decimal is already taken care of. So this becomes 0.7, or 7/10. What is 2 minus 7/10? Well, 2.0 minus 0.7, make sure you line up the decimal point. 0 minus 7, can't do that, so I have to borrow from the 2. 10 minus 7 is 3, so I get 1 3/10. So they want to know which of these following equations are true. So first of all, let's take a look at letter A. Letter A says 1/2 times 6 times the quantity of 6 minus 4. We have these parentheses in here. We say that this is the same as 1/2 times 6 minus 1/2 times 4. Well, let's remember the distributive property that says that I can multiply 1/2 times everything that's inside of here. So this would be 1/2 times 6, which is 1/2 times 6. And could I put that in parentheses? Sure. And then it would be 1/2 times 4. Could I put that in parentheses? Sure. Do I need the parentheses there to tell me that 1/2 times 6 and 1/2 times 4 are going to be done before this subtraction sign? I don't need the parentheses because Pemdas tells me that I do multiplication first. So that would work. In letter B, I have 1 3/10 times 2 plus 7 times the quantity of 2 plus 7 is the same as 10 7/10. So let's take a look at this. And I could do this either way. I could choose to multiply 1.3 times 2 and 1.3 times 7. So that would look like this. 1.3 times 2 plus 1.3 times 7. I could choose to do that, but that's going to add more decimals into my life, and I prefer to keep the decimals out, so I'm working with whole numbers first. So I'm just going to solve this like this. 2 plus 7 is 9. What's 1.3 times 9? Let's take a look. 1 3/10 times 9. 3 times 9 is 27. 9, 10, 11. That becomes 11 7/10, which is not 10 7/10. So those are not true. Remember that multiplication is just a shortened way to add a whole lot of the same thing many times. Just like we can add the same number repeatedly, we can also multiply the same number repeatedly. And that, when we multiply the same number over and over again, is the E step of Pemdas. So they want us to replace the variable with the given number and then evaluate. So all we're going to do is we're going to take out the variable, and we're going to put in what the value of the variable. So you see here, h equals 4/5. So that means I'm going to take 2 times h, or 2 times 4/5, and I'm going to add that to 2 1/5. Remember that I need to be multiplying before I add. That's what Pemdas tells me. That's what the order of operations tells me. So I'm going to multiply 2 times 4/5. 2 over 1 times 4 over 5. 2 times 4 is 8. 1 times 5 is 5. 8 over 5 is the same as 1 3/5. So that becomes 1 3/5 plus 2 1/5. 1 plus 2 is 3. 3 plus 1 is 4 over 5. This becomes 3 4/5. You go ahead and give letter B a shot, and when I'm finished erasing the page to make room for letter B, we'll talk about it. Almost there. This is easily the most entertaining part of the video. You're welcome. All right, let's talk about this. We have 3 times x, or 3 times 2 1/4 minus 2 3/4. So do you see how I had x here and I replaced it with 2 1/4? Now, keep in mind that we are multiplying here, and you can't multiply whole numbers or mixed numbers without turning them into fractions first. So 3 would be the same as 3 over 1, and that's going to be multiplied by 2 over 4, or 4 times 2 is 8, plus 1 is 9 over 4. 3 times 9 is 27. 1 times 4 is 4. 27 over 4. Well, I know that 4 goes into 27. Let's think about this. I know that 4 goes into 25 times. 4 goes into 24 6 times. 4 goes into 28 7 times. So I want to go with 6. That would be 6, 24, 25, 26, 27, and 3/4 left over. So that becomes 6 3/4 minus 2 3/4. 6 minus 2 is 4. 3 minus 3 is 0 over 4. So I'm not going to write 0 over 4. I'm just going to have my answer of 4. Then we have our last problem here. 2 4/9 plus t to the second. T to the second, I'm going to rewrite it up here just so I have room, ends up being 5/3 to the second, which means I'm going to multiply 5/3 times itself. 5 over 3 times 5 over 3. 5 times 5 is 25. 3 times 3 is 9. 9 goes into 25 2 times. That gets us all the way to 18. We still have 18, 19, 20, 21, 22, 23, 24, 25, 7. So that's 2 7/9. I want to take that 2 4/9 and add it to 2 7/9. So I know that 2 plus 2 is 4. 4 plus 7 is 11. 9 is the denominator. Now, 11 over 9, that's improper. So I'm going to take 9 out of there and put it into one whole. So that means 5 wholes and 2/9 is my final answer. The important thing when you're looking at these kind of problems is just to take your time and remember the rules for operations with decimals and with fractions.